My name is Garima Desai, and I'm a sustainability manager at Samsung Semiconductor. And today I'm going to talk about how we can create a sustainable semiconductor industry for the AI era. So the agenda of this presentation is as follows. We're going to start with talking about the relevance of sustainability today. Then we want to talk about the environmental impacts of the semiconductor process. Then I want to place this within the context of AI and energy usage. And then we can talk about ways to reduce and abate emissions within the semiconductor manufacturing process. And then lastly, we can touch on some challenges and constraints to creating a sustainable industry. So starting with sustainability, the most commonly used definition is from the United Nations in 1987, and it says, meeting the needs of the present without compromising the ability of the future generations to meet their own needs. And why is this important today? If we look at this IoT analytics graphic, we see this is what CEOs are talking about in Q1 of 2024 prior to the previous, or in comparison to the previous quarter. And if we look at sustainability here, we see that it not only covers a large range of topics from energy efficiency to renewable energy and emissions, but it's also sort of the highest and most important on this list. So it's a very important subject right now for CEOs. It's one of the top topics. We also see a well of brand new global legislations happening in Europe, the United States, Canada, globally. These are all legislation to report our emissions for each of the companies. For example, the SEC, the Climate-Related Disclosures, or CSRD. Oh, and I should mention that we're actually going to see these same legislations coming up for Japan and Korea as well in the future. This is a chart I made that actually talks about, rather than legislation, voluntary initiatives. So this chart, I mapped out some of the big tech companies, including my own Samsung here, and I talked about what our voluntary goals are. So these are net zero goals. Some of them are by 2030, which is just right around the corner, and some of them are up to 2050, and this is for scope 1, scope 2, scope 3. And again, these are voluntary initiatives taken on by companies, so it's very relevant today. And by the way, if you don't know what the scope emissions are, this graphic is very famous and very helpful. Essentially, scope 1 and 2 are direct, or scope 1 is direct emissions from the building facilities. Scope 2 is purchased electricity, and scope 3 is emissions from the supply chain. So now let's look at semiconductors and what their environmental impact is. So if we look at this graphic, we can see that there's a lot of inputs and outputs to the semiconductor manufacturing process. As for the inputs, we have chemicals, gases, water, different types like bulk gases versus other gases, electricity, packaging, water. I think I already mentioned that. But these are all inputs that are really important to the process. And then we have these outputs, which are environmental externalities. So air emissions of greenhouse gases and otherwise, solid waste, wasted water, wasted materials. And this graphic actually ends at the product, but there's a lot more beyond the product, because once you create the semiconductor, there is the use of that product, the disposal of that product, which also creates an environmental impact. This data from SEMI-SCC talks about what is the carbon footprint of a semiconductor. And I want to note, this is a very, very hard question. This is very difficult to measure. There's not going to be one answer. It depends. It depends on what device you put the semiconductor in. It depends on what type of semiconductor it is. But just take this as a general estimate from SEMI-SCC. And it says that semiconductor devices produced in 2021 have a lifetime CO2 footprint of 500 megatons. So 500 megatons, I know you don't know what that means, and I don't either. But let me put it like this. 500 megatons is equal to 500 billion metric tons. I'm in California right now. I'm very close to San Francisco. If I were to fly from San Francisco to New York, just my one seat, my one, passenger emissions would be 1.5 metric tons. And we talk about how sort of wasteful flying is for emissions. Here we're talking about 500 billion metric tons. So I just put that in scale, which is that, this is not small. Semiconductors have a really large footprint. And the graph here is really important because it shows where these emissions come from in the semiconductor cycle. So we see that 16% of it come from the supply chain. 21% come from manufacturing, and actually 63% come from the device use. So using the product, plugging it every day and charging it up. So um, that's what this graphic shows. I think it's very important to note. And then this graphic, also again from SEC, shows the electricity related and the non-electricity related emissions. So for the device use, it's mostly just going to be from, again, plugging in that device and using it. But in manufacturing, we can see that a lot of the emissions actually come from not from electricity related emissions. So it's other manufacturing processes that release the emissions and the gases. But regardless, if we look at the total, a lot of it is coming from electricity. And that's why renewable energy is critical, crucial, so important for the semiconductor industry. Okay, so AI, where does AI fit into this? This is an estimate from the IEA. You may have seen this before, and it basically aggregates the global electricity demand forecast for data centers, AI, and cryptocurrencies. And as we can see, right, we can look at 2024 where we are, maybe somewhere around 500 to 600 terawatt hours, but we can, in just 2 years, we can potentially at the highest be moving up to almost double 1,000 terawatt hours, right? And then lower estimates are a bit lower, but it just shows you that how far we might be going in our electricity demand. But on the one hand, that we have this large electricity demand from AI, we also have this other part, which is how much revenue it's going to generate for the semiconductor industry. It's a very, interesting factor for the semiconductor industry. These are McKinsey estimates, and they show that the impact already shown has been about $5 to $8 billion worth of revenue for the semiconductor industry from AI, and this could go up to at the max 95 billion. So it's something to think about as well. Now we can talk about the different methods for reducing emissions within the semiconductor process. So first of all, process gases. I mentioned this a bit earlier. The semiconductor manufacturing process uses these gases that have a high global warming potential, GWP. And this basically means how hot is that gas in the atmosphere, right? So is it like carbon, more than carbon, or less than carbon? That's kind of the estimate of that. And Deloitte estimates show that the manufacturing processes, 80% of the fluorinated gases are released into the atmosphere at the end of the process. So they're not being captured or taken away, basically. And the good news is that some of these gases can be replaced. So for example, perfluorocarbons, PFCs, can be replaced with NF3, nitrogen trifluoride, which has a lower global warming potential. And we also have abatement technologies to work on this as well. So for example, Samsung has created and innovated this regenerative catalytic system. It's in this image here. And it's essentially a scrubber that we put on our fab, and it helps capture those fluorinated gases, which is really important. And then also you may have heard of CCUS, carbon capture, which I think will be becoming more used as we go forward. And then also recycling. This is also a method to reduce. So we can recycle water, gas, and materials like gold and copper, and also gas. So for example, Samsung is recycling the neon gas in our chip manufacturing. And also water recycling is not only important for sustainability, well, for the environment, but also it's because of the environment. We're having scarcity, which is driving these companies to want to recycle their water more and more, or need to rather. You may know about digital twins, right? It's talked about all the time, and it's made to help find areas of efficiency. The good news here is that this is where you can use sustainability as well. You can use the digital twin to figure out not only efficiency, but also waste and pollution and emissions, and figure out where that can be assessed as well and reduced. And lastly, there's a circular economy. So rather than having a straight supply chain that goes sort of from the earth and then ends up back in the earth as waste, we can have a circular loop that creates the product and then recycles the product and reuses parts of it and creates more of a closed loop circle, which is obviously way better for the planet. So that's also a method as well. And then lastly, just for, some challenges and constraints, I really just want to focus on the main one, which is a lack of renewable energy availability. So if we look at, South Korea, This number is a little bit old, just a couple years old. This is only about 8 or 9% today of renewable. And then we have a large portion of nuclear and fossil fuel. Even in America, a large portion is fossil fuels. And then if we look at somewhere like Singapore, which has very little land, meaning there's not that much space for nuclear power or solar panel or wind power, we can see that they're using a lot of fossil fuels as well. So we need to think about how we can get more renewable energy in some of these countries, how we can reduce fossil fuels and figure out ways to reduce our emissions through the energy that we use. So in summary, sustainability is a critical concern for the semiconductor industry, and there are many methods to abate emissions within the manufacturing process, as well as just improving the efficiency of the use of the chip, the use of the chip going forward. AI poses a new challenge for sustainability with the high requirements of electricity, but it's also an opportunity for semiconductors to gain more revenue. Sustainability. And in short, sustainability is an interdisciplinary field that requires the participation of all stakeholders. So, in short, you are a part of this journey. How you work, and whether you're an engineer or a policy person or a lawyer or you work in marketing, sustainability is going to become more and more relevant for you. So, I hope this presentation was helpful, and thank you so much.